All right. Question 3, first date September 2024, Physical Sciences paper 1, vertical projectile, which says a ball of mass 175 grams falls from a tree. All right. It falls from a tree and breaks the glass roof of a wooden cabin directly below it. Okay. So it falls from a tree, then it breaks the glass roof. Okay, then the ball continues to fall freely until it hits the ground. The velocity time graph below represents the motion of the ball from when it left the tree until it hit the ground. So this is from when it left the tree up until it hit the ground. Interesting. So the very first question, define the term projectile. That is for 2 marks. Projectile, that is an object which has been given an initial velocity and on which the only force acting on it is the gravitational force only. Okay, an object which has been given an initial velocity and on which the only force acting on it is the gravitational force only. Okay, then 3.2 says calculate the distance the ball fell from the instant that it left the tree until it hit the glass roof at 0.8 seconds. So it's very important to collect the data. Okay, so at 0.8 seconds, what is our initial velocity? They said from the instant that it left the tree. So before it left the tree, its velocity was equal to 0. So our initial velocity is 0. Then what is our final velocity? When it hit the glass roof at 0.8 seconds, our velocity is equal to 0.84. So that is our final velocity. Right, so you can choose direction. Right, so let's choose direction here, up as positive, down as negative. Okay, so 3.2, we've got initial velocity, which is 0. It's very important to collect data, just like I said. So let's do that. And then final velocity is 0.84. Then what is our acceleration? That is negative 9.8 meters per second, because it's going downwards, right? Meters per second squared, right? And then what are we looking for? We are looking for delta x. Okay, we also have delta t, which is 0.8 seconds. Which equation of motion can we use here? Okay, I can use this one. Vf squared is equals to vi squared plus 2a delta y. Right, so why did I write delta x here? This is delta y. We are dealing with vertical motions here. Okay, so Vf, that is 7.84 squared, is equals to Vi, that is 0 squared plus 2a is 9.8, right? And then delta y, that's what we are looking for. And therefore we can do our calculations. So let's do this. 0 squared plus 2 into negative 9.8 delta y is the same as 2 into negative 9.8 multiplied by delta y. So to avoid unnecessary calculations, we can just divide by okay, we can just divide by 2 multiplied by negative 9.8 on both sides, right? Yes. Therefore, how much are we going to get? This is going to cancel this, right? And then remember I said 0 squared plus 2 into negative 9,8 delta y is the same as 2 into negative 9,8 delta y. That's why I'm doing this. I'm avoiding unnecessary calculation. So let's take our calculator. 7,84 squared divided by 2 into negative 9,8, that is equal to negative, so our delta y is equal to negative 3,14 meters, but we cannot leave a negative answer, so this is delta y is equal to 3,14 meters downwards, right, downwards. That is 3.2. Therefore, let's move to 3.3, which says, for how long was the ball in contact with the glass, right? So 0,8, 1,0, can you see there? We need to try and find for how long was the ball in contact with the glass roof, okay, for 1 mark. So the difference between the two, 1,0 and 0,9, is going to give us the time in which the ball was in contact with the glass roof. So you will just say 1,0, which is 1 minus 0,8, and this is equals to 0,2. So 3.3, 0,2 seconds. That is the correct answer. Okay. Then 3.4. Let's move to 3.4. Let's see. 3.4 says, calculate the average net force acting on the ball while it was in contact with the glass roof. So we are looking for the average net force that is acting on the ball while the ball is in contact with the glass roof. So which formula are we going to use here? Which formula are we going to use? The Newton's second law formula in terms of momentum, right? Which says F net is equals to delta P over delta T. And if you manipulate change in momentum, this is the same as M into Vf minus Vi all over delta T. But now we know the time in which the ball is in contact with the ground, which is 0,2. So there in your formula delta T, you will just substitute 0,2. What do we want here? We need to substitute, we want F net, right? But we need to substitute the mass, and I think we were given the mass in the statement, and then final velocity and also initial velocity. Let us take a look on our sketch. So what is our mass? Our mass is 175 grams. That's a problem. We do not want a mass which is in grams, because this is not a chemistry, it's physics, it's paper one. So we need to convert that into kilograms, and when we do that, we just divide by 1000. So that is 175 divided by 1000, and this is how much? 175 divided by 1000 is going to give us 0,175 kilograms, right? So you substitute there the mass 0,175, but before we can substitute, let's try to find the final velocity and the initial velocity when the ball was in contact with the ground. So when the ball was in contact with the ground, that is the difference, right, between 1,0 and 0,8, right? So 1,53, can you see 1,53? That is our velocity at a time of 1 second, right? And then check 0,8. 0.8 second, that is the time that corresponds with 7.84, the velocity of 7.84. So what is our initial velocity and what is our final velocity between the two? 7.84 and 1.53. 1.53, that is our final velocity, right? That is our final velocity. And then 7.84 is our initial velocity, right? So let's substitute that. So we said our delta F net is equals to, we said our mass rather is 0.175 into VF. We just said VF is equal to 1.53, right? 1.53 minus our initial velocity, which is 7.84 divided by the time in which the ball was in contact with the ground, which we calculated it to be 0.2. Therefore, let's take our calculators. 0.175 into 1.53 minus 7.84 all over 0.2. This is equals to negative 5.52 newtons, right? But we cannot leave a negative answer, so this is 5.52 newtons downwards because we chose down as negative, right? And then now they are saying 3.5, we are required to calculate its 3 marks. Calculate the speed the ball reached, okay, when it hit the ground. So when it hit the ground, that is at t 1.7, that is at 1.7 second, it then hit the ground. And what is our initial velocity? Our initial velocity is 1.53. Can you see? From 1.53, boom, then we hit the ground. So we want that we want final velocity, right? The final velocity. We have the initial velocity, which is 1.53. We have the time, which is 1.7. We also have acceleration, gravitational force, which is negative 9.8, and we are looking for final velocity. So which formula can we use? Which equation of motion can we use? We can use this one. 3.5 VF is equals to VI plus A delta T. That's the correct equation of motion that we can use to find VF. So we are looking for VF. VI, remember, is 1.53 plus acceleration is 9.8. Delta T, I think that was 1.73, or it's 1.7. So that is 1.7. And therefore our VF is equals to 1.53 plus negative 9.8 multiplied by 1.7. This is giving us negative 15.13 meters per second. VF is equals to 15.13 meters per second downwards. So that is downwards there. Then 3.6, let's see, 3.6. How does the magnitude of the force exerted by the ball on the glass roof compare to that of the force exerted by the glass roof on the ball? So check. 3.7 is therefore saying name the physics law used. So these two questions are linked, right? So the magnitude that the ball will exert on the roof will be equals to, right, will be equal to the magnitude of the force that the glass roof exert on the ball because of Newton's third law of motion, right? Same magnitude but different directions, right? So here 3.6 6, you will say equal to. They will be equal. Then name the physics law which is used, that is Newton's third law of motion. Newton's third law. Newton's third law of motion, right?